Hey stargazers, the furthest human-made object ever built was Voyager 1 and 2. But they weren't launched by the most powerful rockets. Instead, they literally stole speed from planets by slingshotting their way out of the solar system. This is called a gravity assist. Let me explain how it works. The gravity assist, also known as a gravity slingshot, is a technique that allows spacecraft to use the gravitational pull of a planet or moon to gain speed and change direction without using extra fuel. It's a very clever trick that helps conserve resources while traveling vast distances at great speeds. So first, we launch that spacecraft on a regular old rocket, sending it on a trajectory to pass near a planet, say Venus, like the Parker Solar Probe did 7 times from 2018 to 2022. As the spacecraft approaches the planet's gravity pulls it in. And as it gets closer, that spacecraft would speed up, and when it flies past, it gains energy from the planet's motion. This slingshot effect gives the spacecraft a boost, sending it on its way faster and more efficiently. Think of it like falling toward the planet and missing. That acceleration is a huge boost. Because of gravity assists, the Parker Solar Probe is now the fastest moving spacecraft in history at 430,000 miles per hour. One fun side effect of this is that the spacecraft is literally stealing momentum from the turning planet, but the planets are so big relative to spacecraft that there's no need to worry about it. NASA has used gravity assist for decades, with missions like Voyager, Cassini, and New Horizons all relying on it to reach distant parts of our solar system. But gravity assist isn't just a tool of the past. It's also playing a crucial role in one of NASA's upcoming missions, the Europa Clipper. The Europa Clipper launched in fall of 2024 with the goal of exploring Jupiter's icy moon, Europa. Europa is one of the most intriguing places in our solar system because beneath its frozen surface lies a vast ocean, and scientists think there might actually be potential for life there. But getting to a small moon around a large planet far, far away is not easy. If we just slapped it on a rocket and pointed it at Europa, the Europa Clipper spacecraft would need a huge amount of fuel and time to make the journey. That would likely make the mission impractical or even impossible. Instead, the Europa Clipper spacecraft plans to use gravity assist to slingshot around several planets. First, it will perform a flyby of Earth, gaining speed before heading out toward the outer planets. Then it will use another gravity assist as it swings past Venus and Jupiter, adjusting its trajectory and accelerating as it goes. This carefully planned path will help it save fuel while still allowing it to reach Europa in just a few years after launch in the 2030s. By using gravity assist, Europa Clipper will take a much more efficient path, making the journey cheaper and faster. When it arrives, the Clipper will carry out a series of flybys, analyzing Europa's surface and subsurface in high detail. The spacecraft will map its ice shell, measure its magnetic field, and even study plumes of water vapor that erupt out of Europa's surface. So next time you hear about a spacecraft reaching the furthest corners of the solar system, remember, gravity assist is one of the secrets behind how we were able to explore those distant worlds. It's an incredible technique that allows us to explore farther, faster, and more efficiently than we could without it. Whether it's studying distant moons like Europa or venturing into the unknown reaches of space, gravity assist is helping us unlock the mysteries of the universe. Who knows what amazing discoveries are just a gravitational slingshot away. Until next time, stargazers, keep looking up. For more stargazers, click the video below. Don't leave me hanging, come on. Click it.